Hi guys, so this video that I'm about to make is about amides. This whole lesson is quite a long lesson. It's about acid chlorides or acyl chlorides, another name for them, amides, and then polymers. So this will cover quite a few days worth of work. So with the amides, I'm going to make sure you know how to identify the products of amide reactions and explain hydrolysis, and then we'll go into polymers from there. So first of all, amides. Their functional group is a carbon to oxygen double bond, and then that carbon has a nitrogen bonded to it. Now you can have primary, secondary, and tertiary amides, but we only deal with primary amides at level 3, which is where there's a nitrogen and 2 hydrogens. Do not get these confused with amines. We've covered amines already. The amine functional group is just this part here. It doesn't have the carbon to oxygen double bond. Big difference is amines are bases, amides are not. Okay, so they're very, very different in terms of their reactivity and so on. Naming amides, I'm not going to go into it too much. All you do is put amide at the end of it. So if you've got 2 carbons, 1, 2 here, it would be ethane amide, okay, as opposed to ethane. Pretty simple. Preparation, so how are amides made? Here are some reactions we've already covered so far. You've just covered ammonia plus acyl chloride or acid chloride and amine plus acyl chloride. We've just covered those in the previous part of this lesson. And ammonium carbonate plus a carboxylic acid, we covered that in the carboxylic acid part, and then ammonia plus an ester, and again we covered that in the ester part of the topic. So we're not going to cover those. What I do want to look at is hydrolysis, as this is the most common type of question around amides. So we covered hydrolysis of esters already, like up here. Here is a triester, a fat or an oil. And hydrolysis of this is where hydro meaning water and lysis meaning splitting. So we're splitting this using water. So we're splitting the ester functional group there, there, and there. And that's how we get our alcohol, our triol, and then our carboxylate ions in this particular example. So going back to amides, the hydrolysis is very much the same. There are 2 different conditions, acid conditions and base conditions. Okay, so let's look at examples of these. So acid hydrolysis of an amide. First thing is either both acid and base hydrolysis. The functional group splits here. Okay, when it splits here, this part, if you've got acid conditions, becomes a carboxylic acid. Okay, this part here is essentially an amine group. Okay, that's been separated off. Because you've got acid conditions, you can't form a basic amine. You can't have H3O plus ions and basic amine present at the same time. What happens is the amine will react with the acid, it will gain a proton and form an alkyl ammonium ion. So the alkyl part just means it's an amine ion. Okay, so we need the square brackets around there and then a plus because it's gained a proton from the acid in the acid conditions. So acid hydrolysis produces the carboxylic acid and the ammonium ion. Base hydrolysis, same thing, splits at the same part. We've got a carboxylic acid sort of part here and an amine sort of part here. Because you've got base conditions, you've got OH minus ions present, you can't form a carboxylic acid. The acid and base would just immediately react with each other. And so what happens is that you can't form the carboxylic acid. What actually forms is a carboxylate ion. Notice the difference between here and here. The only difference is this H has been donated to form the carboxylate ion. So again, this might be an example, ethanoic acid. This would be ethanoate ion. Okay. Now, because it's base conditions, there's nothing stopping an amine forming because amines are bases, and that's why you get an amine as a product. So your first things you have to do when you're looking at questions in exams that are hydrolysis of amides, first decide whether it's acid or base hydrolysis by looking at this part here. And then you need to remember that acid hydrolysis forms an acid and then the ammonium ion. Base hydrolysis forms the carboxylate ion and the amine, which is a base. Okay, there's lots of examples in your SciPad to go through that. What I'd like to move on to straight away is looking at polymers because it's related to this. So polymers you covered in level 2, and the main polymers you covered in level 2 were addition polymers. Addition polymers are formed when you have a carbon-to-carbon double bond in the monomer and it breaks and the monomers are just added together. Here's ethene and it forms polyethene. Okay, it's an addition reaction where the double bond breaks. The type of polymerization we cover this year is condensation polymerization. Okay, addition polymerization is not covered this year. Condensation is. So let's go down and have a look. So we need to introduce a thing called an amino acid. You might have heard of an amino acid before in kind of your everyday life, and biologists probably have heard of it as well. So let's look at an amino acid. This is the general structure. This R group is what is different. You might have one amino acid, another one, and they'll just have different R groups, different carbon groups here. So what's the important things with amino acids? The first thing is they have two functional groups, and it tells you in the name what they have. They have an amine functional group here, okay, and another part of the molecule, they have a carboxylic acid functional group. So these are molecules that have both an amine group and a carboxylic acid group, but on different parts of the molecule. That's really, really significant, because what can happen is you put another one next to it and so on, and this amine group reacts with the carboxylic acid group and it forms an amide. Okay, the amine and the carboxylic acid combine, the OH comes off, the N goes in there, and you form an amide. You look over at this end, I'll look again, here is a carboxylic acid, here is an amine group, here is another amide, and we can just keep doing this. If I just copy and paste like this, and what we get is an amide group here, an amide group here, an amide group here, an amide group here, making, I get rid of all these, a polyamide. Okay, forming a polyamide. Poly meaning many, amide obviously the amide functional group. So amino acids, as you might know, are the building blocks of proteins. Okay, most of the things that animals are made up of, most of the sort of molecules that animals are made up of, are proteins, and they are made up from amino acids. Okay, so when an amino acid combines, we form a polyamide, and the correct term, full correct term for one's from a polyamide from an amino acid is a polypeptide. Okay, these are essentially the same thing. These are just ones made from amino acids. So here's the example again here. Here is the amine group. Here's the carboxylic acid group. The OH comes off. Here's another of the same molecule, okay, the same monomer. The H comes off here, and then you'll see the carbon to oxygen and nitrogen bond there. So that's an amide link, or another name for it is a peptide link if it's made from amino acids. So polyamides or polypeptides are made in the exact same way as amides are from carboxylic acids and amines. The key significant part on why they form polymers is they have two functional groups. They have the amine functional group on one end and the carboxylic acid functional group on the other side. So if it was just, if we were to color that in and it was just a carboxylic acid, then it can't form a polymer. This can form a polymer because the monomers, which is this and this, can continually just form in a big long chain there. Okay, and this is how proteins are made. All right, sticking with polymers. The other type of condensation polymer that we talk about are polyesters. You would have heard that term in terms of fabrics. Clothing is made out of polyester. Well, guess what a polyester is made up of? Many polyester functional groups. Okay, let's look at this diagram here. It's a little bit complicated, but what we've got here is a dicarboxylic acid. Forget about what the middle part is there. Don't worry about that. We have a dicarboxylic acid. So what that means is we have a carboxylic acid functional group here and another carboxylic acid functional group here. That can combine with a diol. A diol has two alcohol functional groups, one here and one here. You'll see that this molecule, the alcohol part here, will combine with the carboxylic acid, and we know from our ester lesson earlier that carboxylic acids and alcohols make esters. You join these two parts here, the OH comes off, the H comes off here, and you form an ester link. Now, what would happen is we would then get another one of these, put it down that end, and we would have this carboxylic acid group bonding with this alcohol group and forming another ester link. And then these can just repeat, forming polyesters. Okay, so it's the same as esterification. It's just happening multiple times. And again, the key part with why polyester forms, and not just an ester, is that we've got a dicarboxylic acid, so it's got 2 carboxylic acid groups, and it's reacting with a diol. It's got 2 alcohol groups. So the reason I've covered both polyamides and polyesters is that they come up quite often in terms of hydrolysis as well. Okay, so hydrolysis of a polyester can occur in acid or base conditions, and the same thing happens as normal hydrolysis with an ester. The functional group breaks there, forming the carboxylic acid again, and then the alcohol. That's if it's acid conditions. If it's base conditions, it's going to form carboxylate ion and the alcohol. Okay, with an amide, with a polyamide, the hydrolysis is exactly the same as what we saw up here, acid and base hydrolysis. So that really concludes the main parts of this topic. I'm going to be making more videos that are going to be going through exam questions related to this, because we've gone through all the theory, but really we need to do some practice. All right, let's quickly go back to our learning objectives. You should be able to explain hydrolysis of amides, acids and bases, and explain how polyamides and polyesters are formed, and then, of course, the hydrolysis of those. All right, thank you guys. I'll see you again soon. Bye.